Okay, let's take a look at our function, our graph of our function. In this case, we've got a parabola. And we're going to go through the basic characteristics of our parabola. We're going to start with our domain. So our domain is what we're looking at for our domain is as we go from left to right, where does our graph start and stop in terms of our x values? And we're going to look at this from negative infinity to infinity. And if we look, even though it looks like it doesn't go all the way off, the fact that our graph continues off the top of the page tells us that it's going to keep going forever. Therefore, our domain for a parabola is going to be negative infinity to infinity. And that's just telling us that x can be any value. Now our range, on the other hand, since our domain looks at our x values, our range is going to look at our y values. And our range, therefore, is going to look at our y-axis from bottom to top, from negative infinity to infinity. So if we start at the bottom and we start coming up, where does our graph start? Our graph starts right here at y equals -1. So that -1 is going to be the first digit in our range, the first element of our range. And then if we look, our graph just keeps going up forever. It's heading towards that infinity. So the other side is going to be infinity. We're always going to use the parentheses with our infinity. But because our point -1 is on the graph, it is part of it, meaning our function can give us -1 as a result, we're going to use a bracket. And all the bracket is telling us is that that point is included in the range of our function. So that's domain and range. Now let's take a look at our x-intercepts. And our x-intercepts are just quite simply where our graph touches or crosses our x-axis. And so you can see we have one at x equals -1, and then one more at -3. Then our y-intercepts, and we'll only ever have one y-intercept. If we have more than one y-intercept, it's not a function, because that would mean we would have two y values for x equals 0. So we come over here, where our function, where our graph crosses the x-axis or touches the x-axis, is where that y-intercept is located. And so our y-intercept is located at y equals 3. There's our intercepts. Our vertex is right here. And our vertex is simply the point on our graph where our graph changes directions. And it's also the lowest point or the highest point. In this case, it's the lowest point. So our vertex is our coordinate pair, -2, -1. And that's also our minimum. And it's also our point where as we go from left to right, again, as we go from left to right, if we look at what our y values are doing, so our y values are decreasing, 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 decreasing. They stop at the vertex, and then they start increasing, 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 and going on. So our increasing interval is from -1, or -2, sorry, -2 to infinity. Always use the x value, even though we're talking about the y values, what their y values are doing, we're talking about it in terms of our x. And then our decreasing interval, -infinity to -2. And remember, we're always going to use parentheses with our vertex, because at this point, if I draw a little stick figure, the graph is at rest, the function's at rest. It has a zero slope. It's neither increasing nor decreasing. If you think about it, if you're at the bottom of a well, you're neither going up nor going down. You're just there. All right. So our end behavior. Colors again. End behavior. So as x goes off towards -infinity, what's our y value doing? So if we look, as x goes off towards -infinity, if we look up here, our graph's pointing up. Therefore, y is going to infinity. And then as x goes to infinity over here on the right side, if we look again, we're pointing up. So y is also going to infinity. So our parabolas, along with our absolute value functions, your end behaviors are always going to be the same. They're either both going to be going up towards infinity, or they're both going to be going down towards -infinity. Now, last piece of the puzzle, and come back here. We have a vertical line, an imaginary line. It's going to come down through our vertex. And this is our axis of symmetry. And what this line represents is a line of symmetry, where we could fold one side of the graph over on top of the other side of the graph, and they would mirror each other perfectly. And what this helps us out with is, if I know that right here I've got a point that's 2 units away from my axis of symmetry here, I also have a point that's 2 units away on the other side. So if you ever need to graph, or when you need to graph a parabola, if you graph one side, so here it's 3 units. So here it's also 3 units. You can find the points on one side and then mirror them over the axis of symmetry to the other side. And that, in a nutshell, are the characteristics of our function.